Okay, let's go ahead and get started. So, uh, events. So we have KubeCon Seattle coming up December 10th through 13th. So we have 2 talks that have been accepted. We are currently working on a network service mesh demo, and we'll have more to talk about that later in the meeting. And we would like some help with people who are interested in either building the demo or evangelizing the demo in some way through the form of a podcast, blog, or a medium of your choice. We also have a FIDO mini summit paper that was submitted, or proposal that was submitted for network service mesh by Tom Herbert. And I believe that's still pending acceptance unless Tom has heard about it, has heard any results. Let's see. So before we start, is there anything anyone would like to have added to the agenda?
Cool.
Okay, I will take that as a no. So let's start with the agenda board since I managed to room it.
Excellent. So let me actually, I forgot, I'm the one who's actually following that link now.
Great. So SRLV work, I believe that's currently pending. I need to actually update the content in that, but there were some improvements to VPP that should be coming down the line that should make that a lot easier. So I'll make sure to add that in to that. So in terms of tasks to add sidecar containers in network service mesh, which was added by Pratik. Is Pratik on?
I don't see him, but I was helping him with this, probably in the middle of the summer. I was just putting a note in the issue because now that he should be able to do this now that we've gotten rid of Minikube.
Yeah, I was going to suggest take it on, but let's set up an action item to ping him offline and ask him if he needs any help.
Yeah, I'm fine if you want to give me that action item. I can do that.
Okay, so we'll add a action item on that. Okay, so converting SRV config map to a plugin. So I put that on hold in the temporarily. I'm going to get back to that once more important things are complete. X Factor CNFs, things are progressing in that area. I'll talk a little bit more about it later today. Migrating errors to Go is an ongoing process. Anyone who spots an error that is not handled by Go errors, please convert it over to use Go errors.
So we're looking for an erroneous use of error.
Sorry, couldn't understand you, Ed.
I said, so we're looking for an erroneous use of errors?
Exactly, looking for erroneous use of errors. Simultaneously, if you're writing new code, please use the Go errors as well. And so what the Go errors gives us is, so once the error is passed, so the way Go's errors, or errors in general work in Go, is that if you create an error, it has a string embedded in it, maybe a little bit of extra metadata that you've added in, and then you pass it up. Eventually that string gets printed somewhere. But the thing that's missing is the context. Where was this error? When was this error created? Where was this error created? And so that information is injected automatically by Go errors, and it works with Logros so that if it ends up being printed out to the event stream, then we actually get a stack trace of that error. So it'll be extremely helpful so anytime you have an error that you need to use, like, please reach for Go errors instead. So in terms of becoming a Kubernetes workgroup member, so there were 2 things that conflicted in this scenario. So we had Kubernetes workgroup versus a CNCF workgroup, and Do you know what's going on with that, Ed?
So I don't think we're currently moving much forward on that at this point, primarily because we're still thinking about, the SIG networking folks would very much like us to be a Kubernetes working group. The Kubernetes folks, when we last talked about this, were in the middle of redefining what it means to be a working group. And so there was general confusion as to sort of what the criteria were, how to engage with that project, that process, et cetera. And since then, we've been very busy actually writing code and trying to get to something to demo at KubeCon. So we haven't really picked that up. I do have one question on the board here, which is, there are some issues that I recently put a lot of documentation into that I'm not seeing on the board. Do I have to put magic tags on them for them to show up?
Oh, well, so what ends up happening is they don't get added automatically. So do you see that add cards on there?
Ah, okay.
So we need to move them onto here. So
I think when the other option is when you file the issue, you can tag them in this project as well. So I think going forward, if you want them to show up here when you open it, you can do that when you open the issue.
Perfect. Just wanted to make sure. Cool.
We should check to see if it's possible to do default tags.
Yeah.
Yep.
Definitely. But moving back to this, I just wanted to make sure we close this discussion here. So because we've discussed a few different times as a broader project, this Kubernetes working group versus CNCF one. I don't know if we ever, so what is the status? Did we decide which way we're going or as a community here?
Yeah, I don't think we actually came to enough of a conclusion based on the recommended work to go and start writing up some of the collateral involved in proposing this as a Kubernetes working group. We just haven't gotten all the way to thinking about collateral because of some of the other things that I mentioned. Now, things change. It's been long enough since we sort of came to that decision. It was probably about 3 months ago that, I'm perfectly open to revisiting that decision. But speaking purely personally, I'm much more focused right now on code.
Right. So Frederick, I know when you and I were in Amsterdam for ONS, we discussed this a bit, and my preference was to maybe try to move us towards more of a CNCF working group. So I guess I'll just kind of state that's that. But I fully admit that I haven't done anything to make that happen either. So, but that was kind of my preference in our discussions.
Yeah, to be honest, at this point, I think I would prefer CNCF as well. I think we should add this as an action item maybe for next week, or not an action item, a agenda item for next week. So we can talk about it a little bit more in detail and work out is this something we want to progress now? Because there is work involved, and that one of the risks that we have is that we end up spending a lot of time on this, and end up not producing demo code. So that is one of the risks. But simultaneously, if we were to become a CNCF or Kubernetes group before KubeCon, then there would be a significant boon in visibility for becoming such a project. So there are benefits in that area.
Cool.
Okay. Okay, so we have L2 forwarding with VPP example. Tom, are you on at the moment?
Yes. Can you hear me?
Yes. Do you?
I'm working on it. I don't have a lot to show yet. I'm hoping to borrow some of your time today or tomorrow, Frederick, if I may.
Okay, and just so you know, we spoke about the network service endpoint and so on. So one of the things that I'm actively working on is the network service endpoint, where I'm basically trying to clean up those APIs. So so this will help you in that respect.
It will, but also the data plane work that has been merged recently, I think, makes things a lot clearer from that standpoint as well.
Cool. We'll go over the data plane stuff and make sure that you understand it. So let's add an action item for you. Get a hold of me on that, and we'll have a discussion on what it looks like.
Yeah, I'm tied up in some packaging stuff this morning. So, but I will as soon as I get to a resolution on that, I'll contact you this afternoon.
Cool.
You know, is right.
Okay, and so with that, we'll add more to the agenda or to the project board over time. So I think it's first iteration. Okay, so moving on. So we have the KubeCon demo work that we've been doing. Ed, I'll let you have the floor. Might be a mute button involved.
You're right, there is a mute button. So we talked about a little bit about this last week, and so I'll just go through it really quickly in case there are people who missed it. But there's an active desire to do demos at KubeCon for network service mesh. And so we're sort of looking at what can be accomplished between now and then and the kind of generic thing we could do. At a high level, we were sort of talking about doing a simple chain demo where you've got two nodes, you've got a client pod that runs on one of them. It obviously only consumes Kubernetes interfaces. That gets cross-connected via VXLAN, and then we chain through two network service endpoints. And in this case, via MEMIF and then via direct MEMIF for reasons of efficiency. Now, one thing to be clear about is I don't expect network service wiring to be working for KubeCon yet. So that's, for this case, it would probably be one network service endpoint explicitly consuming the next network service endpoint instead of some of the really fun things that we're looking to do with network service wiring. But it still sort of shows the basic idea. Getting more specific, this is sort of one of many options. So I think sort of option 0 would be whatever the VNFs, or the CNFs that are being produced with the VNF-CNF comparison. We could definitely show something like that because we're hoping to be able to deliver to VNF-CNFs as well. But another option we can look at is Sarah's story, which is, for those of you who've looked at the narrative deck, when we tell the story of Sarah and the secure internet connectivity, we talk about a chain where maybe you have a firewall and then you have an IPsec gateway. And so it turns out that building a stateful firewall with VPP is easy because you've got stateful ACLs, or at least a simple one. And with VPP, you also have support for IPsec. So it becomes quite doable to build an IPsec gateway. And so we could probably show this as a specific choice of network service endpoints, or CNFs, in the chain. Getting a little more realistic, we could look at doing replicas, which means that we would actually be picking out one network service endpoint for a network service out of maybe 3 to 5 replicas. This gets a bit more ambitious. We'll have to see kind of where we get to in time for KubeCon. And then we had some conversations about how to graphically visualize the topology and whether we might or might not get the auto self-healing working in time. If we get the auto self-healing working in time, then we could show cool things like you have a client pod, it's connected to a network service endpoint. You kill the network service endpoint. The client pod gets automatically connected to a new network service endpoint, providing the same network service. So you get a nice smooth auto healing behavior. That again is a stretch for KubeCon, but if we just get to something as simple as showing the simple chain demo, I think everything as we get past that point, it becomes gravy. So I know we had a lot of commentary last time. Does anyone have anything sort of different they wanted to talk about around the demo, or areas they want to contribute to it?
Hey, Ed, so this is Chris. So a couple of things. I think we sort of have the high level takeaways and what we want to, have people come away with when looking this over. Number 2, I think some sort of visualization of the topology is essential. This whole CLI terminal kinds of demos just don't fly. And I would say, based on some other things that I've done with Kubernetes clusters, that we do have close to the number of APIs that we would need to go in there, pull out, and then render. I guess number 3, we need to start maybe laying this out, and I can do that in terms of some sort of high level wireframe or mock-up, keeping it simple and maybe trying to scope our goals so that hey, this is absolutely attainable. Let's get this nailed up, ready to go, rock solid, and that sort of thing. Stretches are fine, but I do think we are limited in time, given that there's going to be Thanksgiving holiday the end of next month. So I think the way to pursue here would be number 1, just lay out the mock-ups or wireframes, make sure we got the flow. Number 2, look at the mechanics or the tools that we could deploy so that we could start maybe assembling this GUI. I do have a person that's doing exactly sort of the same thing right now in terms of visualizing Kubernetes clusters with nodes and pods and VPPs. And I'm hoping that we could reuse some of that work, including those specific GUI modules. And then, we'll have a place that this is running, and then we can start to build this thing. Now, no specific promises right now in the visualization. However, as I mentioned, we are on another project rendering this same type of information. So if we have the APIs, we can go in there and pull it out and render it and show it. And I think it'll be a pretty good demo.
No, I think that would be awesome. So would you mentioned a couple of things. One is laying out wireframes and flow, which is very valuable. The other is the possibility of being able to contribute to getting a graphical topology viewer going, which is also awesome. Understand it's not a commitment, but it's great that you're stepping up. On the laying out wireframes and flow, would it be of assistance to give you write access to this deck so we can start collecting some of that here?
I'm sorry, when you say write access to?
This Google slide deck.
Oh yes, by all means, please, yes. And I can plug that right in.
Yeah, so that's great. And anybody else who has stuff they want to contribute to this, I'm happy to rope in anyone else who wants to do work on this. And then in terms of the APIs needed to feed the topology graphical stuff, it would probably be useful, and we can take this off into the IRC channel or issues or whatever to sort out kind of what things we need in the API. Particularly since one of the things that I'm starting to look at in the Inter-NSM API is sort of how do we monitor connections. And so we might want to look at the API being used for how network service managers monitor the connections between each other and see if something similar northbound from the network service managers might be useful for this purpose. So, cool. Anything else from folks?
Yeah, so as I mentioned, I'll start updating this doc stat, and we can obviously talk about this throughout the week and report back next week.
Cool, excellent. So that was the end of the demo stuff.
Okay. Yeah, and just a quick note. So for the UI on the demo, like I don't think it has to be pretty or anything like that. Just as long as it shows the information to start off with, and if we have time, we can always go back and make it look nicer. But even just showing the information alone is, outside of a CLI is, I think, extremely valuable.
Yep. Okay. Absolutely. Yeah. We'll keep it simple and absolutely attainable. And if there's any stretch things to make it look more beautiful, great. But as I mentioned, yeah, we'll get this, working and see what we can do from there.
Cool. I'm really excited. Thanks. Thanks for helping out on this.
Cool.
Okay. So Inter NSM API. Ed, back to you. You're popular today.
Yeah, well, I also have a tendency to cluster my agenda items in the same place. So
fair enough.
Yeah. So basically, we had talked. We need to figure out the API that we're going to use for the network service managers to talk to each other, and so I started taking a swag at that. And I had originally been calling this the NSM to NSM API, which, as it turns out, is a terrible name. And so Sergey had suggested that I call it the inter-NSM API. Let me go ahead and find the right proto file to talk through. So here's the one. Okay, inter-NSM.proto. And so sort of laid this out as a proto file where you have basically a remote connection request, where you request a remote connection, a delete remote connection, and an update remote connection. And keep in mind, these are the connections that are leaving a particular node. So, you know, we're not locally cross-connecting. These are, we've discovered the network service we have to cross-connect to is on a different node. We need to go ask its network service manager to help us negotiate the appropriate remote mechanism for this cross-connect. For this, we go through and I don't seem to be seeing the whole file. Let me try view here and see if that helps. This is better. So the other one that I have here is we have update cross connect, and then we have monitor remote connections. This is the one I was mentioning, Chris, where I'm starting to look at how do you stream updates about remote connections. And this one is just looking at how you do it peer-to-peer, but we might look at something north to south. For this, we've got remote connection ID. You know, effectively it encapsulates the ID of the source network service manager and the destination network service manager, because they're the ones who are managing the connections, and then the source and destination connection IDs. Basically, the idea here being, if we have a certain amount of autonomy here, then if your peer network service manager goes away and comes back, it can discover relevant information about the state via monitoring connections.
So, quick question:
Yep,
when you say,
I mean, hang on. Oh, okay.
Right?
Sorry.
yeah, when you say north to south, like what use case are you thinking of in that scenario? Like,
Okay.
it's not very clear to me.
Okay, so I think of the monitor remote connections call here, right, in the inter-NSM API. I think of that as an east-west call. It's one network service manager talking to another saying, I would, you know, please let me know information about these connections because I want to monitor the connections I have, your opinion of what's going on with the connections I have for you, right? So for example, you might find out, oh wait, the other guy has sent me an update that says he thinks the connection's been closed. I don't think the connection's been closed. Clearly something is wrong. Or, you know, I have, you know, metrics that say I've sent a gigabyte on this connection to the other end, and the receive metrics coming back from the other end are telling me that he thinks he's received 0 gigabytes or 0 megabytes of data at all. Therefore, we probably have a problem. But when I talk about north-south, what I'm basically thinking is you also have an interesting place, and this is where the visualization comes in, where you might want to monitor connections north-south in the system. And so they probably won't be the same call. In fact, they definitely won't be the same call, but they might be in the same style. Does that answer your north-south versus east-west question?
Yeah, that makes sense.
Cool, cool. So we define a remote connection state, sort of basic connection states. And then the sort of meat of it gets to be this remote connection object, which has, you know, obviously its ID, its state, the network service name that it's, you know, of the destination, the network service endpoint name, in other words, the particular concrete instance providing the network service, and then, you know, contains the remote mechanism in use, which sort of tells you, okay, what we have here is actually a VXLAN tunnel. Here's a source and dest IP in the VNI, and the connection context. Now, with a remote mechanism, we get sort of this notion of fully versus partially specified. When you request a connection, you may have partially specified the remote mechanism. For example, saying, one of the things I can do is I can do VXLAN, here is my source IP, and here's the list of VNIs that would work for me, right? But when it gets fully specified coming back, you've got concrete instances of all of that for the connection. Then you sort of get the remote connection request that's saying, okay, I have a remote, you know, I am asking for a remote connection. So you get all the sort of partial specification of the connection. And then, by the way, here are the supported remote mechanisms that you can pick from on your end. And then the reply comes back with success or error or the actual fully specified remote connection. And then remote connection updates, which is what comes back from the monitor remote connections call. It just feeds you back remote connections and possibly some set of metrics about them. Does all that sort of, in the rough sense, make sense to folks?
Well, I have a concern about basically exchanging the updates between the NSM, especially if this information can be used for some logical decisions. I mean, we're looking into the implementing a routing protocol like a BGP, because we have to track adjacency, we have to track the state changes. I mean, it's a huge work on the NSM. I mean, I don't see like a huge benefit of replicating BGP implementation in the NSM.
Yeah, but we're not actually replicating fully BGP implementation or anything like that, because all we're really talking about is having good information about the state of this one connection. Right? So for a particular connection, you want information about its state, just to make sure that you agree with your peer about its state. It's not talking about syncing sort of a full database of your BGP rib out to the world so people see how you see it. It's much simpler and more straightforward than that.
Okay, well then it's a RIP implementation, because that's what RIP does.
That's a fair analogy. That's somewhat of a fair analogy, but yeah, we could talk about sort of what makes sense in terms of monitoring. The thing I've been thinking in terms of was it would be really, really, really handy to know if the connection was not actually functioning. If we have disagreements about what's going on with the connection's functioning, then we probably have a situation where we need to tear down the connection and connect to a new network service endpoint for that network service. That sort of thing. Other than that, I think it's, correct me if I'm wrong, your concern is about the monitor remote connections.
Yeah, exactly. First of all, I mean, even if we lose the one of the NSM, the gRPC connection will be gone from both ends, even from the surviving end. So basically, that connection is gone, and ideally, all the data related to that connection needs to be invalidated. And then, when the new NSM comes back up, it will need to reestablish everything to be on the fresh side instead of pulling the old, possibly stale information from its neighbor.
Yeah, so the part of the problem with that is that the data plane may be perfectly fine. It may just be the network service manager that's been restarted. And if that's the case, then you don't want to go tearing down the data plane just because you've restarted.
There's a second use case as well. So I would like to make the assertion that an upgrade is the same as a network service mesh system failing. And if you treat them the same way, then you don't want to destroy your data planes when you upgrade, generally. And so that's another use case that this would help tremendously with as well.
There was a request to increase font size. So, yeah, I mean that was kind of my thinking there. It would be highly disruptive if a peer's network if a network service manager going down resulted in the wholesale destruction of all the cross connects and then having to reestablish them. That's kind of a big blip in the system, and it may or may not be necessary.
Well, I wasn't talking about breaking the data plane. I mean, yes, it can survive if the node is up. But I was talking about the clearing the control plane portion, which could change, for the time when the other end was down. When it comes up, it can always refresh, rebuild it, but based on the not from neighbor information, but on the actual client of the local node.
But there is an aspect of the state information here that is actually state information of the connection. So the data plane has its notion of things. The pure NSM has its control plane notion of things. And you have to be able to get back to a world where you can map what's happening in the data plane to the actual semantic qualities that are living in the NSM, right? You have to be able to get back to a place where you know, okay, that cross connect is actually talking to that remote NSM, which means I know who to go ask to delete it when it comes time, and I know what ID to use to go delete it when it comes time. Just something as simple as I want to go and delete a connection on the far end after I've been restarted. requires a certain amount of state information. And our options are basically either we either store the information local to the network service manager, but that the interval in time between when the network service manager goes away and when it comes back means that we have no notion that the state that we stored locally is actually currently reflecting the world. Or we can obtain the opinions of our peers as to the state of the world, and we at least know what the rest of the world believes. And we can reconcile with that with things like, what do we actually have in our damn data plane, right?
Yeah, but I mean, how useful could be the information about myself if I got just restarted and hearing that from the peer? I mean, you know, basically they are talking to me about my local connection. So that's where I mean, I feel a problem lies.
Well, so I mean, the thing is, you have to sort of, it depends on, again, which data is stored where. No, there is a useful utility in knowing that your remote peer believes that it has certain connections with you. Now, whether that actually reflects what's in your data plane, the pods that may still be alive, that's neither here nor there. But if you don't have some way of bringing your remote peer's opinion of reality into reconciliation with what's actually happening on your node, then you could have a remote peer, for example, that sort of permanently leaks connections and therefore tunnels because you never asked them to delete them because you don't even know they're there, and it has no notion that they're there, that you've had a problem because you don't tell it anything.
Well, okay, all tunnels eventually will go away when the pod using them will be removed. So, I mean, the namespace is gone, tunnel is gone.
But that pod can hang out in limbo with no workable connection for some time.
Well, that's the trick. I mean, it's the application responsibility to detect, hey, I lost the connection. I'm gonna kill myself to restart, trying to reestablish it. I mean, that's the whole concept of Kubernetes. Problem, pod crashes, tries to reestablish the state, not rely on some other mechanism. It's like a loose consistency. Anyway,
it also allows us to auto heal, which is a really nifty feature, because then you can have things that go wrong in the system without disturbing the application. Because the applications aren't used to thinking at network level. I mean, if I've got an application pod that's running that has requested secure internet connectivity, it absolutely is not used to the notion of I've lost my connection to my secure internet connectivity. It's used to the notion of I've lost my TCP connection, but that's a whole different layer in the system.
Yeah, let's see how it gets implemented, because I mean I see some really big complexity, and well, I mean, I guess the real implementation will be able to answer whether it's valid or not valid.
Absolutely, absolutely. Cool. Anybody else have any thoughts? Okay, cool.
Okay, so head straight into the data plane API documentation.
Are we looking at the API documentation, or are we going down to update on the data plane work?
You're next on the agenda still. So if you want to talk about it.
If Sergey is okay, I'd kind of prefer not to carry 3 agenda items in a row. I'm happy to come back to it. But it's starting to feel a bit like a monologue to me.
Yeah, let's move that to the bottom then. And okay, so let's see. In terms of the network, there you go. You're at the bottom now.
Yep.
Okay, so X-Factor CNF updates. So I haven't done much modification yet this particular week because I've had, it's only been Friday since our last meeting, and I was planning to work on it tomorrow. So I don't have any major updates on that. There are a couple of new people who are on the call, so I'll just give it a really quick message as to what it's for. So what this is trying to do is provide guidance for CNF vendors. A CNF is a VNF that runs in a container in Kubernetes and makes use of Kubernetes constructs to scale. And So what this is taking things that we've learned from in building applications in the enterprise environment and how those scale horizontally, and taking information that we know about how networking VNFs work, and saying if we were to combine both of these worlds together, then what should such a system look like? So it's effectively guidance for how do you build scalable cloud-native network functions. And so they're just basic, very simple, high-level heuristics. And so if you're interested in helping out build what those are, the link is in the agenda, and would more than happy to have you help in. So I won't go on much longer than that on this. Anyway, Sergey, you're next on the data plane work.
Well, there was no change since since last Friday. Basically, the local portion is done. It got merged, and I'm waiting for you know, to finalize that inter NSM API to be able to add. I mean, whoever's planning to add the VXLAN feature to be able to talk to remote NSM. So that's pretty much it.
Okay, cool. So we have an update on packet.CI. CI. Andre, you have the floor.
Yes, this PR has been merged today, and we have initial build process and run integration test against Kubernetes cluster deployed in Packet.net. Need some time to understand how stable it is.
Nice. And there was a bug that was discovered in I guess you would say interaction between Packet.net and Container Linux. So just so you know, I've looped in the Container Linux people to work directly with Packet in order to solve some of those issues we were talking about before. So expect some more resources to help with the stabilization of it, at least on the infrastructure side.
Yeah, that's great. By the way, it looks like something going there because it became more stable for past day.
Yeah, we found a couple bugs. So there was actually some problems with networking we found in Packet.net that they had been trying to trace down, and so you actually helped expose that information. So, so that was really helpful.
Okay.
So there's still a little bit of instability that I'm expecting to still be there, but hopefully with the Container Linux and Packet.net people working together, we should resolve those. So.
Cool. A quick question, Andre. Did you happen to get a chance to know whether or not huge pages were enabled?
Not yet.
Okay. So hopefully we can get that sorted out, because if huge pages are enabled, then I think that clears the road for us to actually start implementing some CI for the new the VPP data plane stuff, which would also be deeply comforting. Functionality without CI makes me nervous.
Okay, perfect. I will check it today.
Thank you.
Cool. Okay, so Michael, Masiak, and Taylor, KubeCon demo for VNF CNF comparison. You have the floor. Also, double check your. Sorry, go on.
Okay, I can give a quick status on what I've been doing at least. So since last week, I've run some benchmarks using some of our setups on the Packet machines, and compared to what we're seeing on the CSIT test bench, the results are about 30 to 40% lower. So we still have some debugging to do here to verify that we get the proper performance on the Packet machines. Otherwise, I think most of our test cases, at least on Packet, are running. We can do different types of chains for CNFs, and we can do multiple network functions and change for VNFs as well. So most of the basic functionality is available through scripts, and right now I think we've just started out on the templating and trying to automate things a bit better than just running a ton of bash scripts to set everything up.
Bash scripts make the world go round.
Oh yeah, oh yeah.
And then do.
Awesome. So go ahead.
That's good, Ms. Taylor. So we also have planned out a lot of the OpenStack part. So for what we're doing for KubeCon, we'll actually be doing all of the comparisons on Kubernetes and then trying to do as close as possible on OpenStack. So part of the last few weeks has been working on getting that going at the same time. And this is hopefully all reproducible as well as the goal, so that on packet.net you can bring up a OpenStack cluster and then run the similar test. Actually, the using T-Rex and actually generating the packets, all of that should be the same. So it's the VNF versus CNF portion. So as we template stuff out and do a lot of the automation in CI, we'll start having as much as possible common, and that's going to be for both OpenStack, Kubernetes, as well as going between packet.net and CSIT Lab. Our goal is that you could recreate this in other environments. Maybe Amazon Bare Metal might be one of the next ones that we target as well.
Oh, that's exciting. Yeah, no, that's definitely exciting. Cool. So that's a good status update. So just to reconfirm, my understanding was that in terms of network service mesh supporting you guys, the thing you guys really needed was the local MEMIF mechanism working so that you could basically do your cross connects between the CNFs locally on the same node. Is that still correct?
Yes. So the two, I guess the two use cases are having CNFs connect directly to each other over MEMIF, and then the other one, which is trying to match closer to what the VNF side would be a CNF going over MEMIF to VPP, and then connecting to the next CNF, what we're referring to as a snake connection. And we're doing that one specifically because it looks closer to what we have to do in OpenStack since we can't directly connect them. And what we're doing right now, pre-NSM, is mounting volume and then making the MEMIF interface available to the containers.
Yeah, and you know, our hope is that we'll be able to get you something, you know, before you guys need it on November 5th. That actually does that. The hope is we can probably start integration the week before so that you guys could use network service mesh to wire up those containers. And so we get a nice, clean, sort of cloud native approach to the problem. Cool. Thank you.
Okay, and then finally we loop back to data plane API documentation.
Cool. Yeah. So we're trying to sort of piece together the data plane documentation as we go. So different parts of it are sort of in different states of repair. But one thing I did kind of want to walk through really quickly, because it gets to be interesting and important, is I think the section on network service mesh components in the abstract is probably in pretty good shape. And this is mostly just calling out that even though we're extremely focused on Kubernetes, network service mesh actually can operate beyond simply the Kubernetes environment. And this gets to be crucially important as we look at things like, how do we consume network services that are coming from physical boxes in the network? How do we consume network services that are external to your cluster, whether that's some other kind of system or even some other Kubernetes cluster? And so we sort of talk about these components in the abstract. You've got your network service client, which is, of course, when we're talking about Kubernetes, that's just a pod. you've got your L2, L3 connection to some abstract network service, and then you have a network service endpoint, which is a concrete thing in that actually provides your network service.
And quick question, sorry to interrupt you. I mean, you see on this picture, network service endpoint has a single ingress, but in the real life, it's never the case. I mean, in most of the cases, NSC would need at least two connections. One, the ingress from the client, and then probably egress to the service that it's providing. And I mean, have you had a chance to think about it?
Yeah, so there's actually, effectively, once network service mesh has wired up the client to the network service endpoint, what happens behind that network service endpoint is actually not network service mesh's business. So I'll give you a really simple example because it's familiar, it involves Kubernetes. If we have two Kubernetes clusters, right? And so I'm in cluster one. I may have a network service client in cluster one that's a pod. It may have an L2, L3 connection to some network service endpoint that from its point of view is simply external to cluster one. It could happen that that is actually a pod in cluster two, and there could be all kinds of things happening behind that in cluster two. But none of that is actually the network service mesh in cluster one's problem or the network service client's problem. So you could also imagine the case where you have a physical box this is terminating on, where you've got all kinds of weird things happening behind the physical box. Again, none of that is actually our problem.
Okay, so basically, as soon as the client traffic hits the NSC port, we don't care about anything happening after that.
Yeah, as soon as it hits the NSC, whether it's a pod or a physical router, or I've had people talk about it being a neutron network for legacy stuff with OpenStack. It can be any number of things, but as long as we can set up that L2, L3 cross connect between a network service client and a network service endpoint, we're good to go in the abstract.
I would actually be more aggressive in that statement and say that we care about the establishing of that connection, and the moment that anything that happens after that, like the traffic even goes into the interface, it's like we don't really care beyond that point.
As long as we do our level best to get to the network service endpoint, you're right. Did we lose Frederick?
I'm still here.
Okay.
Cool. I'm just reading the document that you sent or that you posted.
Okay. So yeah, and then I sort of talked through some of these in a little more detail with text. Text is great for reading, a little less good for presenting. So we sort of talk about those in the abstract, and then we say, okay, well, the system, when you look at it more broadly, you have some kind of network service registry where you keep a list of network services and the network service endpoints. This is, by the way, in the abstract. In the Kubernetes case, this would just be custom resources in the Kubernetes API server. You've got network service managers, and they have some domain in terms of network service clients and network service endpoints and cross-connecting data planes that they manage. And a single registry may have multiple network service managers. Now, in the Kubernetes case, as you'll see when we get there, this translates to things like node, and the network service manager being in charge of sort of managing all the connections for network service clients and endpoints on their node. Defining this in the abstract is actually kind of nice, because what it gets you to is the realization, number one, how the abstract maps to the actual situation in Kubernetes, where your network service registry is just CRD, custom resources in the API server. The network service manager is just a daemon set. The domain the network service manager looks after is the stuff on a node. The network service clients and endpoints are pods, etc. But then it actually becomes really important when you look at how the APIs work. Because in the abstract, when you look at the APIs, basically the APIs that matter in the abstract case are what we're now calling the inter-NSM API, how network service managers talk to each other. And also then, the patch I pushed has not been merged, that's why the names aren't updated. Hang on just a second. Let me go and actually show the updated stuff, because it's going to be a little easier to read.
And just for a time check, we got 5 minutes left before we have to end.
Okay, do we have other things we need to discuss?
I think the only thing on the agenda that was after this was Romkey's stuff, but Romkey's not here today, so I think you have the rest of the time.
Okay. Why am I not finding Yadox thing? Okay, there we go. All right. Apologies. But so then we talk about the InterNSM API, which is the only thing that sort of we have to worry about at the abstract, and that gets laid out. And one of the reasons it's important to recognize this is Kubernetes-isms shouldn't leak into the InterNSM API, because you may have network service managers that are external to Kubernetes for various reasons, and we sort of talked through this already. And then we sort of. So that's the critical point, is realizing what APIs it's okay to have Kubernetes-isms leak into, and what APIs it's not okay. So for the InterNSM API, you shouldn't have Kubernetes-specific things. But how a Kubernetes-based network service manager talks to its data plane, or its network service endpoints or network service clients, that can be as Kubernetes-specific as it needs to be.
To be clear, like when you start looking at what things care about, like the pods, the clients and the endpoints, like they care about the payload and they care about their local mechanism. They don't generally care about the remote mechanism itself. So you think about, or the local mechanism of the thing they're talking to. So look at the separation of concerns. Simultaneously, when you're looking at the remote connection, the same thing applies. They don't really care about what the local mechanisms are. So when we look at like InterNSM, like its primary thing is about forwarding the information forward and back, and in terms of the service request, service response, and negotiating that remote mechanism connection parameters. And so you can think of it as like, while the endpoints, the endpoint and the client care primarily about give me my service. It doesn't care about how it gets to it. It just cares about like that it's going to receive it. So we're trying to build reasonable separation of concerns in each of these groups in order to simplify the overall system and pattern.
Yep. Do folks have questions, comments, etc.? Cool.
So I definitely encourage people to spend some time after the meeting between now and next week. Like the data plane API stuff is relatively new, so please spend some time with it. Like read up on it, make sure it makes sense. Try to find holes in it, and come back to us with deficiencies that you find. So just to stress the order of importance, it's like where this project is going to be made or broken based upon the overall quality of our APIs. And like, yes, the execution of the implementation definitely matters, because like rubber has to hit the road somewhere. But step one, if we get these APIs right, it'll help simplify our overall path. And so definitely spend the time looking at the APIs, and make sure that they're reasonable, and also, are they understandable? Like if this is the first time you're looking at the data plane API, can you understand what they do? If not, then that's useful information, and we need to work out a way to simplify the message. With that, are there any last-minute announcements or anything that someone wants to bring up? Okay, well, with that, then Thank you, everyone, for attending, and we will see you all again same time next week.
Bye-bye.
Bye.
Goodbye.
Thanks.